How are robots and drones impacting the future of warfare? Hello and welcome to Tech First. My name is John Kutz here. We all see what's happening in Ukraine. Drones have become a key weapon of war and just might be the one key thing helping Ukraine defend against a much larger opponent. What does this mean about the future of combat? And will autonomous humanoid robots eventually become part of the military menu? To chat, we have the CEO and founder of Mach Industries. They're a next gen weapons manufacturer that recently raised $80 million in venture capital. CEO's name is Ethan Thornton. Welcome, Ethan. Hey, super pumped to have you. Let's dive right into it. What is Ukraine teaching us about the future of war?
A number of things. I think the biggest being the importance of unmanned systems. So it was recently published by the Ukrainians that across much of the front, they're actually outnumbered 5-1. They've switched to an entirely sort of unmanned centric means of fighting. This small quadcopters, as we've seen, this is flying for information, surveillance, reconnaissance drones. This is ground-based drones, but it's really clear how big of an unlock unmanned systems are, right? This is the first time in military history where we can actually have intelligent systems control and operate themselves. And that's radically changing a number of things, right? It's pushing out the distance you can sense. It's also pushing out and dropping the cost on strikes, right? Those strikes are then making it much more difficult to defend through centralized assets. So you've seen them pull armor off of much of the front, right? You've seen both sides, and this is also due to proliferated air defenses, but both sides have issues for achieving any real level of air dominance. It's really it's impacting the war pretty heavily.
It's a massive change and switch over in military doctrine, really. I mean, you mentioned air dominance, and nobody's able to actually achieve that. That's been a key thing that people have wanted since World War II. You see in the Gulf conflicts as well. Once you achieve that, then you have the freedom to maneuver, move, get your troops and armor where you want it, and really impact the enemy. Right now, with these tiny systems that can hide anywhere, right? You have this total decentralization of your combat assets. Essentially, it's extremely hard to find them all, target them all, kill them all.
Absolutely. Absolutely.
Let's talk about cost too. Cheap systems are absolutely killing costly systems right now. We see like $1,000 drones, $500 drones killing multi-million dollar tanks, right? We see other examples of that. Drones that are destroying 100 million, $200 million infrastructure pieces like a refinery, those sorts of things. What's that mean about the weapons we need to build and defend against?
Absolutely. I mean, it means we need to be building very large numbers of more attritable systems. I think the first conclusion to jump to is that the U.S. must be building millions of quadcopters and millions of Shahid-style long-range strike drones. I actually don't think if that is necessarily the right path. I think specifically because if we attempt to make our entire doctrine based on that, we will not be able to replicate China's scale. Right. And so sort of by definition, purely doing that is a losing strategy. But these systems are going to play a major role in any war that happens in the future. And so we do need to have prolific manufacturing and very rapid and capable design of both hardware and software.
How much intelligence do they need to carry each one of them? Because I mean, as we've seen in the Ukraine-Russia conflict, hacking is a real thing, right? Electronic interdiction is a real thing, right? If the drone requires communication back to a central base, there's no guarantee you're going to have that. What do you need to build into that drone?
Absolutely. So this is a question of sort of law of armed conflict as much as it is technology, right? I don't think any of us want to see a world of proliferated sort of non-human in the loop unmanned systems, even if that might be the world we're headed towards. I would say it's very, very important to have GPS and navigation, and GPS tends to be the first to go. And so the Ukrainians are mitigating that a few ways. The most common is actually FPV, right? And so they've been better able to secure sort of first person view links to actually guide it themselves. that is rapidly turned into guiding it fiber optically. Now fiber optics are very limited on range. Like you're
Yes.
not seeing 1,000-mile strikes conducted with fiber optics, and you likely won't. That's a really interesting tech. The next is like vision-based GPS and nav, right? And so this isn't necessarily anything. We've been doing this. Tomahawk missiles were actually capable of referencing images to do navigation. But that's become a lot cheaper and a lot more prolific. And this is one of the things Mach's platforms use to navigate.
Mm.
Um, but in this world, you essentially have a map. You're referencing the map with a bunch of different camera data, as well as your sort of accelerometer and IMU data. And that's been pretty effective. Obviously, that's limited in scope, right? So if it's cloudy, if the battlefield's changing a lot, if it's snowy, like that becomes relatively difficult. I think another very interesting one, another one is we'll be deploying is Homeland Signal. Imagine a lot of the assets on a battlefield are actually emitting RF of some way.
Mhm.
A radar by definition has to emit RF. So do comms. And then a lot of what we're seeing is to avoid those FPV strikes, right? They're actually jamming the frequencies that FPV is normally done on. But the second you jam something, you're basically emitting your position
Yes.
at a battlefield. And so you can create this interesting kind of cat and mouse game where if you're jamming, you're revealing your position. You can actually use that to see where an asset is. And then if you're not jamming, obviously you can FPV. I think that's the first stage. There's some really interesting stuff that kind of comes after that. Like I think we'll see very proliferated laser-based comms. That's something we'll be working on, and that other companies will be as well. I haven't seen that used to great effect in Ukraine. You also see very directional RF solutions,
Mm-hmm.
so specifically directed phased arrays. There are a number of different ways to do it. Tracking antennas are another sort of lower tech way.
Mm.
But that's actually where I'd say most of the innovation is happening. And right now I see it as much, if not more, on the comms end than on the actual vehicle level compute end. But that's the really hard part.
It's crazy hard, and there's real challenges there, right? Like, what are your jamming assets, and how do you separate them from your more offensive assets, right? So that if they get taken out, then you don't. And how do you communicate beyond between all these things? And how do you maintain situational awareness as everything is changing in real time? And how do you communicate in this crazy environment and not get hacked? It's insane. So we're going to dive into a lot more stuff, including what you're building. Uh, as before we get there, the future of war looks so mechanized right now, incredibly lethal. Is there even a future for human soldiers? I mean, if you see any of the video that's coming out of Ukraine right now, it doesn't look like humans have that much of a chance.
That's a good question. I don't think there will be a world where human soldiers don't play a part. I just think that part's going to radically change, right? And it's not necessarily a super powerful parallel, but with AI, we're seeing this across a very large number of fields, right? And things you can guarantee humans won't be removed from it are dynamics where like knowing there's an actual human on the other end is very, very important. So a lot of peacekeeping, right? A lot of sort of power projection is important in that way with humans. And then so is a lot of more sensitive work that gets conducted by special forces and others. I think
Mhm.
that we can continue to see humans.
Mhm.
Um,
Mhm.
I do think we'll reach a point where pretty much the rest of combat, certainly anything in the air, most of I think what we can expect to see in the sea will be unmanned.
Yeah. Yeah. So let's talk about types of drones. You're building some flying drones, and we'll get into that, what they look like, what they're doing, what your focus is right there. Flying drones getting all the press right now. We see some watercraft, some boat drones as well. There's a few other kinds. Will we ever see anything like a humanoid robot? Will that ever make sense for combat, or will that just be too big and too slow?
I think there are certain applications. I expect most of it to be airborne, um, or unmanned surface underwater or unmanned underwater vehicle.
Mhm.
In urban combat, there are certainly worlds where it could make sense, right? So our world is designed for humans, and so if you're looking for an unmanned system to navigate that world and sort of conduct operations in that world, I'm sure there are many applications for a humanoid robot.
Hmm.
Uh, but I think that remains to be seen. Like I haven't seen any
Yeah.
compelling.
I haven't seen anybody build that right now either. I mean, humanoid robots are super hot in a lot of areas, but that's generally manufacturing, logistics. There's some some home applications that people are working on, everything like that. But I just assume that that's coming at some level. But it's really interesting just to kind of speculate. If you were going to build a military today, if you were going to build a military today, knowing what you know, what you would build it with, how you would build it, what you would equip infantry units with in terms of their drones, in terms of maybe spot-like, dog-like robotic dogs that can go out and just give you a view over that ridge or a view around that corner or something like that, right? Without risking your own life to do so. It'd be very different than how we used to build and maybe even how we mostly build right now. Okay, let's talk about manufacturing and scale and decentralization. We talked about cheap as a weapon. We talked about scale as a weapon. You said we can't just go on scale because you can't just build 5 million things. Somebody hacks one of them, and they're all gone. Maybe. What are you doing to decentralize construction of all this stuff?
Absolutely. And I may circle back real quick and touch on my former point. I don't think the reason not to do scale is necessarily because of cyber or because of like the risk of loss of those assets.
Mhm.
I more say that because that is not an area we're going to have an advantage in anytime soon. So American foreign policy and I mean our way of life generally is built on some level of military overmatch. And that means we have to do something better than our adversaries.
Mhm.
There are lots of things we do better than our adversaries. Unfortunately, right now, manufacture of small unmanned systems is not going to be one of them. And so, while it is very, very important to have scale, sort of table stakes to be able to do the production of these systems at some level. And I do think that level is in the millions or tens of millions a year, right? Several orders of magnitude more than we're capable of right now. But we need to be investing very heavily in other ways to maintain overmat, right?
Mhm.
And I say that in hardware specifically. Like I think software's obviously incredibly important, but it's not going to be the differentiator of the next conflict, is my personal.
Mhm.
I hope to be proven wrong there because that is an area we have an advantage. But as I look at it, you're not necessarily going to have an advantage on software. You're certainly, at least in the next decade, not going to have an advantage on scale. Not to say you shouldn't produce at scale. You absolutely need to, but you're not going to win that war. Um, you need to be thinking differently, right? So like
Mhm.
one way you can create overmatch is if you're the first one to deploy these systems, right? Like if you can go and invent to these important architectures and bring them into existence before anyone else. Another way is America is still very, very good at some of this deep domain sort of hardware engineering.
Mhm.
Certainly better across many metrics, especially in aerospace, than China is. And so just wanted to circle back on my
Yeah,
previous
no, that's good. That's great context.
but that's how I feel about things. That's why I founded Mach, right? Like
Mhm.
our goal is to bring that hardware into existence as quickly as possible to create some level of overmatch, to create some level of deterrence. Not to say we won't produce at scale, right? Like
Yeah.
I'm calling from my factory here where we are producing or where we are investing in producing at scale. We do write our own software, but I don't think that's going to be the thing that sets us apart in the next
Mhm.
call.
Mhm. Cool, cool. So that said, then we see things like battlefields as far back or wars as far back as World War II, where people would target the factories that their enemies built weapons in. The Allies targeted tank factories of the Germans in World War II with air raids from at night during the day. We see that today in Ukraine, targeting the factories, targeting sources of production, those sorts of things. And so you've mentioned decentralization as one key there. What are you talking about?
Absolutely. I mean, you hit the nail on the head, right? Uh, the formation of the Air Force was by this group called the Bomber Mafia, right? They had this idea of proliferated strategic fires to take out production. I don't think until the last decade we truly realized that world, right? So in World War II, the big issue was that the Norton bomb sight wasn't precise enough. And then in the 80s through the early 2000s, a lot of people had claimed that that day had come. It had to some degree, but these strikes were still incredibly expensive. A B-2 still cost billions of dollars, right? And so you couldn't conduct this at true and total scale, at least in a non-nuclear way. But we do live in that world today, and that world's only going to become more and more clear, especially to more at-risk nations, right? And so if you're an Eastern European country right now investing in your industrial base, you're in a world where Russia will likely be able to reach out and conduct very, very low cost strategic strikes. And in that world, I mean, it's very, very important to have a secure supply chain, right? And so then you look at, okay, what does a secure supply chain mean? My take is that needs to have sort of three main characteristics, is at least what we believe is MOC, right? So the first is flexibility. You have to be able to rapidly spin up and spin down productive assets. This is important both to be able to continue building the right assets in an ever-changing sort of theater, but more in this context, right? Like if certain factories are being taken out and being brought online, like it's very, very important that you're adaptable. The second is vertical integration, right? So we cannot be relying on China for components. We cannot be relying, like ideally, like raw materials come in, drone comes out. That's obviously unrealistic, at least anytime soon. But to the degree you can push in that direction, it's very beneficial in creating these survivable supply chains. And then the third is this decentralization, right? And this is true for factories. This is also true for platforms. This is kind of true across the board in a world where offensive strike is so much more prolific. But one of the best ways to defend an asset is to make it less worth striking, right? So if you can take a 100,000 square foot factory and make it 10,000 square foot factories, or a 1,000,000 square foot factory and make it 100, it's very, very important, right? And that's one of the best ways to create the supply chain security. That's challenging because there are a lot of unmanned systems that can't be produced in that flexible, decentralized way. And I think that's why it's very, very important that you have these totally vertically integrated companies designing sort of full stack, from full platform design to factory and operations design. I expect that to be a large component of the supply chain and the military industrial base that we need to build over the next several decades.
Super interesting, which is a good segue. What are you building?
Yeah. So we have 3 products right now. Building a whole ecosystem of products in the next few years. The first is a vertical takeoff, essentially cruise missile. So a couple 100-mile range. It's essentially something, the goal is that 2 operators can set this asset on the ground or in the back of a truck and launch it with no infrastructure. And you're trying to take the same capabilities, something like HIMARS, is a lot of these more centralized assets, and then remove the need for this centralized launcher, right? And actually distribute those capabilities to ground maneuver units to allow them to conduct their own long range strike in a way that there's nothing to counter target once the drones launch.
Yeah.
The second I can't talk as much about, but is a high altitude live bomb, low cost, very, very long range strike capability with the same sort of GPS denied nav, hold on signal, all those things that we talked about. And then the third is a high altitude stratospheric balloon.
Stratospheric what? Interesting. What's that for?
Can't talk that much about it. We'll be talking more about it in the next few months.
Okay, interesting. I'm going to guess that's something to do with communications and oversight of battlefields, but that's a pure guess on my part.
Yeah, that's a large part of it.
Yeah. Yeah. Okay, cool. So not totally off base. One of the things you have on your homepage right now looks like a jet / drone / super sexy high-end glide bomb. I'm guessing that's what it is.
It's the first. So that's that cruise missile I was talking about.
Okay. Interesting. Very interesting. Cool. And so the goal is to build things that aren't individually super expensive, that can be deployed and used without massive amounts of infrastructure, and can be used by a small number of people. Is that correct?
Absolutely. Especially with our first round of products, right? So our product thesis will change over time. With these first two products, the one you see on our website, the main goal was to provide the U.S. the ability to conduct low-cost, long-range precision fires.
Hmm.
Um, that will expand in scope, right, as we do more platforms. But I saw that as the most urgent need is if we do have to either arm an ally that is in conflict or go to conflict ourselves, we need the ability to produce these things at scale.
And so to be explicit about that, basically what you're talking about there is there's two options. You have a site that you need to destroy, or an enemy column that is approaching. They're in dangerous airspace. They might be a couple hundred kilometers, a couple hundred miles away. You don't want to send $1 billion aircraft out there and to drop something, gravity, just gravity bomb on it. You also don't have an infinite supply of $1 million missiles, right? Or tomahawks or something like that. So you send up an aircraft somewhere in your own airspace, your own controlled airspace. You let loose this glide bomb. It can fly. It can maneuver a little bit. It has some intelligence. It'll still be a fully precision weapon, but you release it hundreds of kilometers away from where it needs to go. It goes down and accomplishes the mission, and it costs you a fraction of what an actual missile would cost. Is that accurate?
That's pretty accurate. Yes. I can't talk too much about the latter Kana, but the former one certainly.
Mm-hmm. Mm-hmm.
And yes, our goal as a company was how do you provide capability to do these long range precision fires at low cost and then at high scale? And then how do you do that in the supply chain we're describing earlier that is flexible, decentralized, and vertically integrated?
Cool.
So that's been a majority of our work over the last 12 months is bring these products to market. I'm excited in the next year or so to announce some of the next gen stuff we're working on as well.
Cool. Cool. If you peer through a crystal ball, not necessarily your own product specifically, but you peer through a crystal ball and you look at what warfare is, how it's conducted, how it's structured, organized, and fought in 5 years, what does it look like to you? What's that future look like to you?
Is this taking into account procurement cycles, or is this assuming we're engineering it?
I would leave procurement cycles behind, and I would leave all that stuff behind. Just if 5 years from now, what do you think the war will look like, assuming all these systems get built, adopted, sold, bought?
Yeah, I think if we accelerate and sort of deploy sets at the speed of engineering and test, I think we'll see a mass amount of decentralization, right? So I think we'll have the ability to offset China's massive production advantage on naval platforms, right? So I think we'll have a variety of different systems that are able to conduct ultra long range strike on naval assets. I think we'll see very, very proliferated underwater systems, both large systems that launch aircraft and then much smaller systems that collect data and that strike other underwater systems or above water systems. I think this may not be a 5-year thing, but the entire concept of sort of a surface vehicle, I think will become harder and harder.
Mm-hmm.
Especially, I mean, even some of the platforms we're building, I think within the next 5 years, certainly we'll have the ability to strike under like unmanned or manned surface vehicles, hundreds to thousands of miles away for
Wow.
very low tens of thousands of dollars. I think we'll see proliferated sensors really around the globe.
Mm-hmm.
We talked a little bit about sort of where I see our place in that, but I think you'll see a very large number of stratospheric assets. We're already seeing proliferated sort of space sensing. I think you'll see a very large number of fixed wing aircraft, groups 1, group 2, group 3, group 4. I think you'll see a large number of, I don't know if you know sail drone, but depending on if the former thing I said holds true, we may see sail drone if that
Mm-hmm. Mm-hmm.
assets still survivable. What else? I think we can expect to see very, very large numbers of cruise missiles be produced. Like, I think that'll be one of the more capable platforms, specifically in the Pacific theater. Um,
Hmm.
I think quadcopters will replace mortars and artillery,
Mhm.
right? Like,
Mhm.
again, I see that as kind of table stakes. That you have an industrial base capable of producing as many quadcopters as you would ever consider producing 155 or 105 shells. Um,
Wow, and
Ideally
those are
more.
produced in the millions.
Yeah. And I mean, if you look atomically at sort of the manufacturing, there's nothing saying quadcopters shouldn't be actually significantly easier to produce
Mhm.
than these shells, is my take at
Mhm.
least.
Mhm.
Um, I think the architecture of actual quadcopters will change. I
Mhm.
think we'll start seeing a lot more like fixed wing quadcopter
Mhm.
setups. You get similar maneuverability. It really doesn't increase your costs, but if your lift over drag ratio is 5 to 15, that's kind of what you're multiplying range by in many cases.
Mhm.
Um,
Mhm.
yeah, but it's going to be interesting, and that's purely on the platform side, and that obviously points to the larger trend of like, by saying those things, I believe that a lot of the larger decentralized assets will not be survivable in this future. And
It
then again, all these things are going to have to be produced in flexible global supply chains that continue to actually survive in a war where they're employed, right? Like
yeah,
your industrial base has to be relevant in war it's designed to fight.
amazing. I mean, that's arguably that's what won World War II, right? Is America's industrial base for producing ships and tanks and artillery and other things like that, and shipping it out to England and shipping it out to Russia, Lend Lease, all those things. Liberty ships. How many Liberty ships were built, right? That
Yeah,
was
absolutely.
scale manufacturing, building a ship from laying down the keel to launching the ship 3 days, right?
It's
That was where
incredible.
they got it to. It's
So
like,
it's amazing.
yeah,
I think
incredible. Um, it is a crazy world, scary world, dangerous world that we're heading towards, and it requires a rethinking of all military doctrines, right? I mean, you got the U.S. Navy, and their military doctrine for decades has been the carrier strike force, right? Delivering 100, 200 planes to some place a few hundred clicks away from a conflict, doing that safely with your destroyer escorts, with your subs, with your whole carrier task force group of 25 or 35 ships and everything like that, right? And deploying power globally. And there'll be some level of need for something like that, but will it be undersea? Those big targets are really, really tempting, those billion-dollar pieces of steel and humans, right? And really, really challenging to see if those will survive.
absolutely. It'll be interesting to see.
Yeah, cool. Well, Ethan, thanks so much for taking this time. I really do appreciate it. I hope you have a wonderful rest of your day.
Yeah, absolutely. You too.